welcome back to Pathashala. I am Shilpa Pradeep. Electricity is one chapter where students usually memorize the formulas but still feel confused. The reason is simple. We study topics separately. Actually, the electricity works as one connected system. So in this video, I'll explain the major concepts together like electric current, voltage and resistance. First we'll see electric current, what really flows. So in every metal wire there are tiny particles called electrons. These electrons are already present in the wire. The electric current does not create an electrons. So it only makes them to move. So when we connect a battery or a power supply, it makes the electrons inside the wire to move. So this continuous movement of electrons is called an electric current. So whenever we say current is flowing, it simply means the electrons inside the wires are moving. Second one is voltage. Now the most important question is, why do electrons move? Electrons will not move on their own. They need a energy or a push. This energy is provided by a battery or a power supply. This energy difference between two ends is called voltage. Two ends means in the sense the one end of the battery and the other end of the battery. If the voltage is less, the electrons move slower. If the voltage is more, the electrons move fast. That is why devices need proper voltage to work correctly. Small devices like torches needs very less voltage, like 1.5 to 3 voltage is enough to work properly. And the mobile phone chargers need around 5 volt. The fast charging needs around 9 to 12 volts. And the vehicle charging batteries need approximately 12 volts. And also the laptop charging needs 90 to 20 volts. Homes use approximately 220 to 230 volts because the appliances like fans, refrigerators and heaters need a strong energy difference to do heavy work efficiently. The third one is resistance. What slows electrons? As electrons moving inside the wire, they do not move freely. Inside the wire, atoms are present and the electrons collide with these atoms again and again. This collision slows down the electrons, opposes their movement and produces heat. So this opposition to the flow of electrons is called resistance. Materials have different resistance. Some allow easy flow and some block it more. So the resistance controls how much current can flow. So now we will see what is heating effect. When resistance is more, the electrons face more collisions. More collisions means more heat is produced. That is why heater becomes very hot. Thin wires heat faster and fuse wire melts when the current becomes too high. So heating is not an accident. So it's a natural result of resistance. So let's quickly go through the summary. Electric current is the movement of electrons inside the wire, just like water inside the pipe. And the voltage is the push or energy difference that makes these electrons move. Smaller devices need less voltage to work and the home appliances need more voltage to work. Resistance is the opposition inside the wire that slows down electrons, just like traffic signal slows vehicles on the road. Because of this resistance, electrons collide with atoms and heat is produced. I hope the concepts are clear now. In the next session, we'll continue with the more concepts, especially series and parallel connections. So thanks for watching.